Hi folks, I'm Jim from Checkmate Arts, and today I'm happy to show you my electrical mechanical clock design. This video is part one in a series of videos about this clock. Today we are looking at making the clock face, and there is a lot of stuff to see, so let's get started. This is what the clock looked like the first time I assembled all the major parts. The hands are just something I made up real quick and painted gold. The clock face looks a lot different when completed, as you will see. This digital display has menus for the clock settings. The battery backed up clock module always has the correct time even if the clock power is turned off. When the clock is finished, the electronics will all be enclosed. I'll make another video about the electronics later on. I made the back plate and front plate from steel with a computer-controlled plasma cutter, and then I did the metal art finishing. The gears and clock hands are 3D printed in black PLA. I painted them with a brass paint. I could make these brass painted parts from real brass if I had access to a CNC milling machine, but 3D printing and painting looks pretty good. Here I installed the bearing blocks and bearings on the back plate. The bearing blocks and drive shafts are 3D printed. The bearings are inline skate bearings. The skate bearings are overkill for such a small clock, but I designed this to be a prototype for really big clocks to come in the future. Here we have all the big parts and brass parts with the 3D printed hubs and other bits installed. The big gears have magnets installed. A sensor in the clock stand detects the position of these magnets. The backup battery keeps the digital clock going if power is off. When power is on, the onboard computer detects the current position of the gears and moves them to the correct time. This is what the gears and other bits look like from the back side. I paint the back of most parts black because nobody sees the back side. Here we have the gears and the 3D printed spacers installed on the back plate. By the way, the gears in the clock are not the same as gears that are typically used in other machines. If you guys are interested, I could do a video about gears. Let me know if you want to see that or other things in the comments area below the video. I'm happy to answer the questions. The clock face is held together by 4 bolts. The axles for each of the hands go through the face as concentric tubes. The parts all need to fit together very accurately or they won't work. Getting good mechanical parts from a 3D printer is a subject for a whole nother video. The setup for my printer might not work for your printer. Here you can see the assembly from the back side. Magnetic field for the front gear magnet passes through the back gear, so the gears have to be close together or you need a really powerful magnet. Here we have the whole clock face assembled with the 3D printed clock hands. I think these hands I designed look kind of cool. The texture of the 3D printed surface looks kind of organic. Maybe this is better than if they were real brass. Let me know what you think in the comments. Do you think 3D printed and painted is better or real brass would be better? From the top you can see the depth between the gears and the clock hands. Also you can see the 4 bolts holding the 2 main plates together. The hands are pressed on. It's safe to move the hands manually. They are designed to slip without breaking anything. You can damage other clocks if you push the hands, but not this one. This is the clock stand, which isn't finished yet. The magnet sensor is on the left. There's a string of LEDs for backlighting in the center. There are 4 main bolts that hold the clock together. Also, you see the 3 separate drive shafts from the 3 motors. I'll make a video about this stand when it's completed. bolts on the stand line up with 4 of the posts on the clock face. There are female drive sockets you can see on the stand side and male square drives on the clock face axles. So the face just slides on and only needs 4 nuts to hold everything together. I can easily do a custom face design without much added work. So here it is up close with the clock face completely done. There's a video of the clock hands and gears moving after the slideshow. One last picture here and we're on to the video. That's all she wrote for today, folks. Please remember to like my videos and subscribe to my YouTube channel. Also like and share on Facebook. Thanks much and have a great day.